Right, this is section 8.2, exercise number 25. Again, we're asked, does the following series converge or diverge? In this case, it's the series from the sum from n equals 1 to infinity of the square root of n. We would like our intuition to kick in here a little bit, but I'll show you kind of two different solutions to this. The one based a little bit more on our intuition is what's called the nth term test for divergence. This is theorem 8.2.4 in section 8.2 when your reading comes towards the end of the section. And it's just the observation that the individual terms, if we were to write out the first few terms of this series, square root of 1 plus the square root of 2 plus the square root of 3 plus the square root of 4, and so on. These individual terms are getting larger. And we're adding them all up. We continue to just add up larger and larger numbers. And so hopefully our intuition kind of kicks in and says this ought to be diverging. And that's precisely what 8.2.4 tells us. It says that if the terms of the sequence are not going to 0, then the series, by adding up those terms, diverges. There's the only hope we have of having a convergent sequence. We need the individual terms that we're adding up to be shrinking down to 0, to be getting smaller and smaller and smaller. So in this case, we have terms that are getting larger, and we're adding them all up, and so our series diverges. We could also view our series here as a p-series. It's another possibility. So the second sort of possible approach is to view the square root of n. It was a little bit odd, but we could write this as 1 over n to the minus 1/2. And then use our p series test, which is theorem 8.2.2. And because our p-value in this case is minus 1/2, our p-series test says diverges. It's a little bit maybe less intuitive to write this as a p-series, but it's possible. Convince yourself that this minus 1/2 is the right exponent, and then so that's our p-value. You only get convergence in a p-series when the p-value is greater than 1. So since we're certainly not greater than 1 in this case, we can also conclude divergence.